Okay, in this video, we're going to introduce profit maximization, and we are going to use the case of one input and one output. So here I have drawn a production function with labor and output as on the horizontal and vertical axis. Now note that usually we are giving the output price, which we call P. Okay, so that's the output price. We are also given W and R, which are the wage rate and the rental rate of capital. So usually profit maximization, or the profit just by itself in economics, is often abbreviated with pi, and that would be the price of output times the quantity of output, which here we can simply put in the production function, right? Minus W times L. Okay, so here, since we are talking about one input, we actually don't need the rental rate of capital. So it turns out that the choice of L that maximizes this function, because remember P and W are given, it can be shown that this function, or the solution to this function, is written like this, where this is the marginal product of labor, or think about this as the slope of the production function. Slope of the and W over P is of course the ratio of the input price, labor, over the output price. Note that we can slightly rewrite this profit equation, where we are saying pi is equal to P times Q minus W times L. So here I have simply replaced Q as the output and do not express it in terms of the profit function. And then we can solve this for Q, because remember that Q is also here on the vertical axis. And if we rewrite this or solve this for Q, we are getting the following term, where we have an intercept, and note the intercept depends on the profit over output price. And then we also have the slope. And the slope here is W over P. So note what we now have is the following. It says that slope, the profit maximizing output, is where the slope of the production function is equal to W over P. Here we have taken the profit function and we have solved it in terms of Q. And now think about this function here, where we actually have a straight line. So here, suppose that the slope of this function is W over P, and that at some point this function is tangent to the production function. So hence this is going to be your profit maximizing input of labor, okay? And you have your output that you're going to sell here as Q star. Okay? So this would be one way of showing the profit maximization, where we are actually using the production function and then the slope of this line. Now, there is also a second way of maximizing profits, and that way will be very important throughout all the videos, as well as throughout economics in general. So think about, we are again marking here pi. is the profit. That is a function of revenue minus cost. And note that here I have written revenue and cost both as a function of Q. Now, using calculus, we can show that the profit maximizing output, the profit maximizing output occurs where the marginal revenue equals the marginal cost. Okay? So the marginal revenue here is the additional revenue that you're getting from selling one more unit, and the marginal cost is the additional cost you are having if you're selling one more unit. So think about the marginal revenue being $6, whereas your marginal cost is $5. So what that means is that if you're selling one more unit, you're getting $6, but it's only costing you $5. Okay, so you're going to produce that additional unit. Whereas if you have the case where your marginal revenue is equal to $4 and your marginal cost is equal to $5, then you're not going to produce that additional unit because your marginal cost is higher than your marginal revenue. So in equilibrium, both of them have to be equal. Now, you will see that if you're looking at perfect competition and also monopoly, it's the shape of the marginal revenue that changes, but through all market structures, this relationship holds. Now consider the situation where we actually have a fixed price in the market. Okay, so that market price is unchanged. That is actually something that is observed in a perfectly competitive market. Okay, so what this means is that for each additional output that you are selling, you're simply getting the price. So in this case, the marginal revenue is simply going to be to the price. So if we are showing this in a graph, where we have quantity on the horizontal axis, output quantity on the horizontal axis, and we have dollars on the vertical axis, then the revenue is simply increasing. And note that the slope of this line, okay, is equal to the price. Now, the marginal cost is usually increasing. So think about, for example, that we have a marginal cost that looks like this, okay? Then the maximum profit is obtained at the maximum distance between this line here, between the revenue and the cost. Okay, so here, let me write this down. We have the revenue. And so the revenue, the slope of this line is the marginal revenue. And then we also have the cost. And the slope of this line is the marginal cost. So now the question is, at which point is the distance between the revenue and the cost the largest? This represents the maximum. Profit. And you will see that it is, say, approximately at this point here. Look. Note what this point has here in common is that the slope of the marginal cost, okay, is equal to the slope of the revenue, or the marginal revenue, okay? So this is another way of looking at profit maximization.